Hi everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder how babies learn to understand language so fast, even before they can speak it well? This new study dives into the very first moments of that incredible journey. Imagine being just a few days old. You've been hearing the sounds of your mom speaking your native language for months in the womb. But what happens right after birth when you hear that language, and a completely different one for the first time in the real world? Do your baby brain already have a special way of listening to your own language compared to a foreign one? Scientists have seen that babies, even newborns, can tell their native language apart from a foreign one. They also tend to prefer a special way of talking that adults use with babies, called infant-directed speech, or IDs. IDs is that sing-songy, higher-pitched way of speaking that adults often use with little ones. It sounds different from regular adult-directed speech, or ADS. But here is where it gets tricky. Most studies looking at how babies respond to their native versus a foreign language have used the baby talk. Idaho S. This leaves a big question mark, you see. Does baby talk itself make the brain pay more attention to the native language, or does it actually make the differences between languages harder to spot? That is the puzzle our researchers set out to solve. So, they decided to test newborns, just 1 to 6 days old, and see how their brains tracked speech. They compared their native language, Czech, with Russian, which is a different language. And importantly, they presented these languages in both infant-directed speech, that baby talk, and adult-directed speech, the normal way adults talk to each other. They were looking to see if the baby brain actually tracks or follows the rhythm and flow of the speech in a different way depending on the language and how it is spoken. And here is where it gets really interesting. They found that when the babies listened to infant-directed speech, their brains tracked their native language Czech much more strongly than the foreign language Russian. But when they listened to adult-directed speech, that language-specific difference was much smaller or might not have been there at all. Even more specifically, the newborns' brains showed the strongest tracking of their native language in baby talk in what is called the delta band. Now, what is the delta band? Think of it as the brain's rhythm. Like a slow beat, this delta band is really sensitive to the slow overall rhythm of speech. It suggests that from the very first days of life, babies are already tuned into the slower rhythmic patterns of their native language, especially when they hear it in that special baby talk style. So what this all really means is that a newborn's brain is already getting ready to understand language, and it is particularly good at picking up the rhythms of its native language. And that special way of talking to babies, Idaho S, seems to really boost this ability. It's like IDs offers a clearer signal, making it easier for the baby's brain to latch onto the familiar sounds and rhythms. This sensitivity to slow rhythms could be super important. It might help babies start breaking down the continuous stream of speech into smaller pieces, like words. It could also help them focus their attention and lay the groundwork for understanding more complex language later on. So, in a nutshell, the study tells us that newborns can indeed tell their native language from a foreign one, and that infant-directed speech plays a key role in making those native language rhythms stand out at the neural level. This really highlights how important those early experiences are for setting up the brain for language learning. Now, how did they figure all this out? They use a cool technique called electroencephalography, or EEG. Basically, they place tiny sensors on the babies' heads to measure their brain activity while they listened to the stories. They were looking at how closely the brain's electrical signals matched the rhythm of the speech sounds. It is like measuring how well the baby's brain was dancing along with the words. They had 62 healthy newborns, just a few days old, participate in the study. The babies were usually asleep during the recordings, which is actually perfect for capturing brain activity related to speech processing. They were played recordings of Czech and Russian stories, carefully chosen to represent directed speech or adult. Directed speech, the researchers then analyzed the EEG data to see how precisely the brain activity tracked the speech envelope, which is the overall outline or rhythm of the sound. Their analysis, using something called a multivariate temporal response function, or MTRF, showed that the brain's tracking of speech was indeed stronger in infant-directed speech compared to adult-directed speech. This is a key finding right here, confirming that the way we talk to babies matters for their brain's response. They also found a significant effect of the language itself. The baby's brains tracked Czech, their native language, more strongly than Russian. This supports the idea that even at birth, there is a neural preference for the native language. But the most important result came from the interaction between all these factors. They discovered that the difference in tracking between the native and foreign language was specifically present in the delta band, that slow rhythm we talked about, but only when the speech was in infant-directed speech. This is the core finding. IDs amplify the brain's ability to tune into the familiar rhythms of the native language. This is visualized in Figure 2, where you can see the difference clearly. The native language tracking is higher in IDs within the delta band. It is like IDs makes those familiar language patterns pop out more for the baby brain. So why is ID so special? This study suggests it is not just about being cute or getting attention. While IDs does tend to be more engaging, the babies were mostly asleep. Instead, the researchers point to the acoustic properties of IDs. It is often slower, has a higher pitch and a wider pitch range. These features create a clearer, more robust rhythmic structure. Think of it like this. Ads might have a lot of complex overlapping sounds, like a busy street. IDs, on the other hand, might be more like a clear melody. This enhanced rhythmic regularity in IDs provides a better signal for the baby's brain to lock onto. This finding is particularly intriguing because babies hear adult-directed speech in the womb, not typically infant-directed speech. Yet, they respond more strongly to their native language in IDs. This suggests that IDs doesn't necessarily introduce new information about the language that wasn't already hinted at prenatally. Instead, it amplifies the familiar, prenatally experienced rhythmic patterns, making them easier for the newborn brain to process. This is a crucial point. It implies that our brains are wired to use the acoustically richer input of IDs to better perceive the language patterns they've already begun to learn about prenatally, even if those patterns were experienced in a more degraded acoustic environment. The exaggerated prosody of IDs makes the subtle temporal cues of the native language more accessible. So, what are the limitations here while this study is groundbreaking? It is worth noting that they only tested Czech and Russian. Future research could explore if these findings hold for languages with different rhythmic structures. Also, they didn't monitor sleep stages, and sleep can influence brain activity. Future studies might want to look at how different sleep states affect these responses. Overall, this research is a really exciting glimpse into the very beginnings of language acquisition. It tells us that from the get-go, our brains are predisposed to tune into the rhythms of our native language, and that the way we speak to infants can significantly enhance this process. It's a testament to the incredible sensitivity of the newborn brain and how early experiences shape our development in profound ways. This research provides a solid foundation for how babies begin to make sense of the complex world of language, and it's pretty amazing to think about what's happening inside their little heads. Thank you so much for joining me on Rubin's Mind Lab. If you found this as fascinating as I did, please give this video a thumbs up, leave a comment below with your thoughts, and don't forget to subscribe so you don't miss our next deep dive into the science of the mind. See you next time.